All right, welcome back, guys. We are in week 11 now, as you're aware, and we're going to do section 5.8 now. So we have thus far done some applications in our work. We're going to do several more this time. Particularly now that we have knowledge of inverse trigonometric functions, we can do more applications, more types of applications. And a lot of these come down to a process called solving right triangles. This essentially means that we're finding the missing lengths of the sides of the triangle and the missing measures of angles. Perhaps we're given 3 parts of this, maybe 2 angles and 1 side, or 3 of the sides, or something of that nature. But there are 6 parts to the triangle, 3 sides and 3 angles. So we want to use the parts that were given to find the parts that were not. Typically, this is how we're going to set up a triangle where notice that A, B, C, these are angles, and then lowercase a, lowercase b, lowercase c, these are the sides of the triangle, the lengths of the sides. So I'm using uppercase letters for angles rather than Greek letters. And then also, just a little note on that, I'm going to use degree measure of angles rather than a radian measure, just for this particular section. Okay, I've got that. A few tips for solving right triangles. We've done some of this before. If I know 2 sides of the triangle, let me actually go back up. If I know 2 sides, say if I know A and B, then I can use the Pythagorean theorem to find the 3rd side, the missing side. That's a process we've done several times with other applications. Second, if I know 2 angles, then you might remember that the sum of the angles of a triangle, at least in our world, is 180 degrees. So if I want to find the measure of the 3rd angle, if I'm given 2 angles, then I can subtract those measures from 180 degrees. Okay, so those are simpler cases. If neither of these situations are the situations that we're presented with, then I can use inverse functions to find missing parts. And particularly, I'm going to use sine, cosine, and tangent inverse. We didn't talk about the other inverse function, so we're not going to use them. And this is particularly helpful to find the value of a missing side or angle when neither of the above methods work. Note that to find the length of a side, you will need to use sine, cosine, or tangent. But the inverse functions give you angles. So to find the measure of an angle, you're going to use sine inverse, tangent inverse, or cosine inverse, just depending on what you need in the given situation. And we'll see how that all works in practice. Let's solve this triangle. Okay. So if I'm given this triangle, it looks like the information that I have are as follows. I know the length of side B. I'll go ahead and write that down. I know B. I know the sides. B is equal to 10.5. That's the only side I am given the length of. I also know a couple of angles. I know angle A, for instance, it is 34.5 degrees. Let's see if I can make this pen a little bigger. There we go. I also know angle C. C is the right angle here. And I know that the measure of a right angle is always 90 degrees. So I know 3 parts for this triangle, 1 side and 2 angles. I'm going to find the other parts. So these are the known of the triangle. Let's find the unknowns. Let's start by finding angle B, because that seems like the simplest. I know 2 angles, and I know from above that the measure of the sum of the angles of a triangle is 180 degrees. So to find the length of the missing angle, I know that angle B is equal to 180 degrees minus the measure of angle A minus the measure of angle C, which is equal to 180 degrees minus angle A is 34.5 degrees. Angle C is 90 degrees. Put those in my calculator and I get that angle B is equal to 55.5 degrees. Okay, so I have angle B. Now I need to find the sides of this triangle, the 2 missing sides. So maybe let's start, I could really start with either side that I want. Let's find side A. I know A and I know side B. I'll go ahead and write that down. I know that angle A, the side opposite, or the angle opposite side A, is equal to 34.5 degrees. And I know that side B is equal to 10.5. I'm told that. Let's see. Angle A here, side B. I want to know side A. It looks to me as if this angle A is opposite side A and it is adjacent to side B. The trigonometric function that uses opposites and adjacent is the tangent function. And since I'm looking for a side, I'm going to use tangent, not the inverse. So I know that the tangent of angle A, which is 34.5 degrees, is equal to side A, which I don't know the value of, divided by side B, which I do know the value of. It's 10.5. Now I have that set up. I'm going to multiply both sides by 10.5 to get A by itself. So this tells me that side A is equal to 10.5 times the tangent of 35.5 degrees, 34.5, excuse me, which if I put that in my calculator, I'm going to get about 7.22. It's not exact. I'm going to round that to 2 decimal places. Okay, so now I know angle B, angle A, and angle C. So I know all 3 angles. I know side B, I know side A. One thing missing, I need to find side C. I have 2 options here. One is I could use the Pythagorean theorem, or I could use inverses again. I think I'm going to use inverses. Okay, so let's find side C. Let's see, what do I know? I know angle A again. And I know the side adjacent to angle A. This is the side adjacent. And I want to find the hypotenuse to angle A. The trigonometric function that uses the hypotenuse and adjacent is the cosine function. So that's the function I'm going to bring in here. Cosine of angle A, which is 34.5 degrees, is equal to the side adjacent to angle A, which is 10.5, divided by the hypotenuse, which is side C. Now I have to rearrange it a little bit to get side C by itself on one side. I don't like it in the denominator, so I'm going to multiply both sides by C. I have C times the cosine of 34.5 degrees is equal to 10.5. Then second, I can divide both sides by whatever C is being multiplied by to get C by itself. Divide by 34.5 degrees, cosine of that, divided by the cosine of 34.5 degrees. Okay. Let me rewrite that. This is 10.5. So that means that C, side C, is equal to 10.5 divided by the cosine of 34.5 degrees, which if I put that into my calculator, I'm going to get about 12.74, which if you think about it makes sense because this is the hypotenuse. It should be the longest side, so it should be longer than either of the other sides. So we found all three sides now and all three angles. We've solved the triangle. All right. Let's do another example. Very often, at least in this particular course, this is how these problems will be given to you. You're just told, hey, there's this triangle that has the same setup that we had on the first page. And we're given a few features of that triangle. And then I'm asked, using that knowledge, find the rest of the features. So let's do that. I'm actually going to use a whiteboard for this, so I have a little more room. Okay, and I'll write the problem down again, just so you know what it was. I want to solve the right triangle. Solve the right triangle. Right triangle. If A is equal to 3, C is equal to 8. And I'm going to start by drawing my triangle just so that I can get a better picture for what I am looking for. This is my right triangle. This is C. This is B. This is A. Same exact triangle as was written at the beginning of the previous page. This is side C that is opposite angle C. This is side A that is opposite angle A. This is side B that is opposite angle B. That's the setup. And I'm going to fill in the parts I know. Maybe I'll use a different color. I know side A. I know that it is equal to 3. I know side C. I know that it is equal to 8. Okay. I also know angle C. Angle C is the right angle. So I'm going to go ahead and write in that it is equal to 90 degrees. I know 3 parts of this triangle. I can use those 3 parts to find the other 3 parts. Okay, so for this setup, I know 1 angle and I know 2 sides. So maybe let's start by finding the 3rd side using the Pythagorean theorem. That seems like the simplest way to start to me. So let's find side B. I know that a squared plus b squared is equal to c squared. That's always the case with a right triangle. I know what a is. It's 3 squared. I don't know what b is, so I'll write it down as b squared. That's equal to c, which is 8 squared. I'm going to solve for b. 3 squared is 9, plus b squared is equal to 8 squared, which is 64. I'm going to subtract 9 from both sides, and I get that b squared is equal to 55. Take the square root of both sides. I get that b is equal to the square root of 55, which very often in your homework, it's going to want you to write the decimal approximation, which in this case is 7.42. These are applications. Often the decimal approximation is more helpful to us. Okay. So there, we found side B. Let's find the angles. I'm missing 2 angles. I'm missing angle B and I'm missing angle A. Okay. I am looking for angles. Therefore, I'm going to use the inverse trigonometric functions. Okay. Let's see here. If I want to find B, side B, or angle B, let's find angle B. Find angle B. I know a little bit about angle B. I know side A, which is the adjacent to angle B. I know side C, which is the hypotenuse to angle B. I'm going to use those instead of this value because this value is an approximation. These are not. So because I know these 2 features of the triangle, I can use the cosine because that brings in the adjacent and the hypotenuse. So I know the cosine of angle B, which I don't know, is equal to the adjacent, which is 3, over the hypotenuse, which is 8. And now if I want to solve for B, I can rewrite this using the inverse. This means that the cosine inverse of 3/8 is equal to angle B. I can use the cosine inverse option on my calculator to solve this. Cosine inverse of 3/8. If I put it in my calculator, making sure that my calculator is in degree mode, I get 67.98 degrees. Is approximately equal to angle B. And I'll go ahead and write that down. Make sure your calculator is in degree mode if you are asked to write the angles in terms of degrees. Okay. So there's angle B. There's side B. One more thing I have to find. I have to find angle A. That's actually pretty easy at this point. I want to find angle A. Find A. And I know that A is equal to 180 degrees minus angle C. I know angle A and I know angle B and I know angle C. That's equal to 180 degrees minus angle B, which we just found, is 67.98 degrees minus angle C, which is 90 degrees. If I put that in my calculator, I get 22.02 degrees. So I know all 6 parts of the triangle now. I know all 3 angles, and I know all 3 sides. All right, this is probably a long enough video. Let's stop it, and we will continue on in another video.